Hi, everybody. I hope that you're enjoying the first day off due to the nice blizzard we have coming. So, first off, I'd like everybody to meet Fez, the cat I have talked about a couple times. So, here he is. He really likes scratches. We'll let him go now because I'm sure he's not interested in math. Bye, Fez. So, what we're going to start looking at today is how to factor any polynomial you could ever want to. So we're going to use this thing called the rational zero theorem, or sometimes I'll refer to it as the rational roots theorem. This will allow us to find any rational root that we could ever want. So far we've factored or done some sort of quadratic equation. I showed you the nasty looking cubic equation yesterday. So today we're going to see a nicer way to do it and basically figure out what happens if we're not given a factor. Is there a way we could actually make a guess as to what a factor could be? And that's where this rational roots or rational zero theorem comes into play. So it's basically just saying if we have any sort of, any sort of polynomial, it doesn't matter what degree it is, and it doesn't matter what the numbers are, as long as they are integer coefficients, so no fractions, no decimals, as long as they're just numbers, positive or negative, then every zero has this form. It's called P over Q, where P is the factors of the last term here. So give me 1 second here. P is the factors of just the number here. And Q is the factors of the number on the first term over here. So we're going to just basically today be creating a list of what numbers our roots could be. So let's see this in play. Well, I guess a couple other notes first. So first off, we're going to come up with a bunch of different zeros depending on how many numbers we get. Not every one is a root. We will test them tomorrow. But today I just want you to generate the list, start practicing that. So the first note is we want to have positive and negative numbers in our list. So basically, as we go through, we're just going to put a plus or minus in front of every number. And the second thing is, as we're testing tomorrow, it's possible that none of our numbers actually work. We might see an example of that. That means there's no rational zeros. This will just find any of those rational numbers. So for the first example here, we're going to list all the possible rational zeros of this polynomial. So we have 4x to the fourth, minus x to the third, minus 3x to the second, plus 9x, plus 10. And it looks daunting at first. We know this is a fourth degree, and we don't know how to factor these types of polynomials. I don't know how to do it off the top of my head, but I remember the rational roots theorem. So the rational roots theorem says I'm going to ignore every term but the first one and the last one. So ignore these terms right now for today. We'll need them tomorrow. But for today, ignore those terms. We only care about the first one and the last one. So we're going to write out what are the factors of 10. So what we say factors are what numbers multiply to be 10. So we know 1 can work. Pardon me, I forgot a stylus at school of all things, and the stylus I have at home is broken, so I'm going with mouse today. So 1 is a factor of 10. 2 is a factor of 10. 5 is a factor of 10. And of course, 10 is a factor of 10. So this right here gave us our P's, that 10. Now to find the Q's, we're going to list what are the factors of 4 down here. And we want the number, it's a coincidence that it's a 4x to the fourth. You want the number in front. So what numbers are factors of 4? Well, 1 is a factor, 1 will always be a factor. And for 4, we want 2, and we want 4. So those are the factors. So when we create our list of possible zeros, there's probably not enough chart over here, or enough space over here. What I'm going to do is write it over here. To find the possible zeros, we're going to go with put all the factors of 10. So plus or minus, we have to put a plus or minus in front of each of them. 1 plus or minus 2. And I'm putting commas in between just so we know that they're distinct. Plus or minus 5 and plus or minus 10. And that'll be over what were the factors of 4. We came up with plus or minus 1, plus or minus 2, and plus or minus 4. So those are all the possible factors of this polynomial. So that's what we're doing today. We're generating this list right here. So all you do, factors of last number. So up here I'll put, let me write it in the same color. There we go. We want the factors of the last number. Last number over the factors of the first number. That's all we're doing. We'll figure out exactly what we're doing with them tomorrow, but today we got to get this done. Factors of last number over factors of first number. So let's see another example here. Here's a cubic. Now remember, we only did sum and difference of cubes, so that formula doesn't apply right here. So we don't care about the middle terms. We care about first number, last number. So again, I'm going to get rid of the middle terms. So what are the factors of 20? So you'll go through, list them off. So you should get 1, 2, 4, 5, 10, and 20. And now here's the case that we all love when we do this thing. What are the factors of 1? Well, the only thing that goes into 1 is 1. That's why we love this. That's why we love 1. We love small numbers. So what are the possible rational roots? I'm going to get rid of that because I don't care about that today. So what's a list of the possible rational zeros? Well, remember, we want to put the factors of that 20, the last number, over the factors of the first number. So all we're going to do here, so I'm going to go off to the side this time. We're going to go plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. Those are all the factors of 20. And that'll be over, what are the factors of 1, plus or minus 1. And hopefully your plus or minus looks a little bit better than mine did there. So hopefully that's not too bad. As long as we can generate this list today, that's what I want us to get out of today, coming up with the list of the possible numbers. Again, we'll figure out how to use them tomorrow. So real quick, pause the video, try these next two on your own. So hopefully you paused the video. How many of you actually did it? I'm sure Fez would be disappointed in the actual number. So for A, what are the possible rational zeros? We only care about the last number and the first number. So we're going to put last number's factors over first number's factors. So I'm going to abbreviate this as PRR, possible rational roots. So what are the factors of 15? Well, that's plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15, all over what are the factors of 1? The number in front of x to the third is 1. That's just plus or minus 1. That's the answer. That's what we need to come up with today. So then here, for B, we do the exact same thing. What are the factors of 18? And what are the factors of 1 right here? So the possible rational roots, the PRRs, we want for 18 plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. Those are all the factors of 18. We want that over, what's the factors again of 1 plus or minus 1. So that's our answer. So hopefully not too bad. That's the goal today. Come up with these numbers, or what we're going to see on the homework here. I know it's everybody's favorite on iExcel. Let me go ahead and pull it up here. It's going to give you something that looks like this. So it says a polynomial function h of x with integer coefficients has a leading coefficient of negative 11 and a constant term of 1. So here's what you need to know. If it's the leading coefficient right here, that's the number that's going to go on bottom. So leading coefficient goes on bottom. I'm going to abbreviate that to LC. The constant term right here, 1, will go on top. So I'm just going to abbreviate that C. And now we do the exact same thing that we just did. So what are the factors of 1 here on top? Well, 1 is nice and easy, plus or minus 1. Then how about for 11? What are the factors of 11? Well, 11 isn't too bad. It's just 1 and 11. So plus or minus 1, plus or minus 11. Now for my Excel, we're going to have to pick some of them out. So could we have 1 over 11 here? The answer is yes, because we could have a plus 1 over a plus 11 or a minus 1 over a minus 11. So let me get back to my mouse here. We'd select that as an answer. Is there any possible way we could have negative 19 over 15? No. Those two numbers don't even appear in our list here, so we're not going to click that. Could we have a 1? We could have a plus 1 over a plus 1 or a minus 1 over a minus 1. So yes, we'll click that. Could we have a negative 6 over 11? No, 6 doesn't appear anywhere, so we're not going to click that. So if we submit that, we see, I know what I'm talking about. I did get that correct. So that's all you're doing today with the iExcels. Just remember the constant term goes on top, the leading coefficient goes on bottom. So maybe just for our sake, I'll do another one on iExcel here. So we're told that the leading coefficient is 16, constant term is negative 1. So what are the factors of the constant term of negative 1? Well, those are just going to be, it doesn't matter if it's positive or negative, put plus or minus 1, always plus or minus. The leading coefficient is 16, so what are the factors of 16? Well, we could have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. So we come up with those. From that, we're going to try to come up with what are the possible rational roots. So is 1 an option? Yes. If you see 1 for iExcel, I believe it will always be an option. So that's a freebie. Could 1/5 be an option? Is there a 5 in here anywhere? No, there's no 5. Don't click it. Is there a 1 and an 8 anywhere in here? Yes, we're going to click it because the 1's on top, the 8's on bottom, and the signs, you could have a positive or a negative, it doesn't matter. And then 5/4, is there a 5 on top? No, don't click it, submit. That's what we're doing today. So hopefully you get the gist of what we're doing. I don't think this IXL is too difficult. When you get to the problems just like this looks more like what we did on the notes at the beginning of class. You care about the first number, so in this instance a -1, and the last number, in this instance a 2. So we haven't done IXL in a hot minute. So here's just a quick reminder of the grading scale. An 80, a smart score of 80, will get you a 10 of 10. If you go for a 90, that's an 11 of 10. And up to 100 gives you that 12 of 10. So then 75 through 79 is an 8. 70 through 74 is a, 75 through 79 is a 9, excuse me. 70 through 75 is an 8. 65 through 69 is a 7. And 60 through 64 is a 6. I'm sorry, it's late at night. And then from there, it steps down. 50s is 5, 40s is 4, 30s is 3, 20s is 2, 10s is 1. Anything other than 10 is a 0. So please do not hesitate to contact me if you have any confusions. We've got to get this down. So just send me a message. If you want to set up a Zoom call, that's fine with me. Just please do not hesitate to contact me. Other than that, enjoy the day. Hopefully you can find some sort of time to rest. What I've given you isn't too stressful, hopefully. And again, let me know if you have any questions. Have a great day, guys.